ይስጥልን ተማሪዎች እንዲሁም ወላጆች ሰላምታዬ ያላችሁበት ይድረሳችሁ። እኔ መምህር ተፈራ ጥበቡ ባላለኝ በአዲስ ከተማ ሁለተኛ ደረጃ ትምህርት ቤት የፊዚክስ መምህር ነኝ። እንግዲህ ዓለም አቀፋዊ በሆነ ችግር ምክንያት ሁላችንም በቤት ውስጥ ሆነን እየሰራን እንደሆነ ይታወቃል። እናንተም ተማሪዎች እንግዲህ በቤታችሁ ቁጭ ብላችሁ እያነበባችሁ እንደሆነ እንጠብቃለን። ስለዚህ መዘናጋት አይጠበቅባችሁም፣ እየሰራችሁ እያነበባችሁ መቆየት ይኖርባችኋል። ለዛሬ ማቀርብላችሁ የ11ኛ ክፍል ዩኒት 5 ወርክ ኢነርጂ ኤንድ ፓወር የሚለውን ኮንሴፕት ይሆናል ማለት ነው። በዚህ መሰረት ወደ ዋናው ትምህርት እንሄዳለን። መልካም ቆይታ እንዲሆንላችሁ እመኛለሁ። Today we are trying to discuss about Unit 5 concept, which is work, energy and power of grade 11. Unit 5, work, energy and power. So, what is the objective or competency of this unit? Well, after the end of the lesson, we are able to differentiate between work, energy and power. We are able to distinguish between work and force. We are able to correlate between work and change of energy, or so-called known as work-energy theorem. As well, we are able to solve some work problems. Therefore, let's start with the lesson. Students, let me ask you a question. What is work? What is work? What I mean is mechanical work. There are some kind of works like intellectual work or any other forms of work. But here we are trying to deal only about mechanical work. So, work can be defined as what? Work in physics can be defined as the dot product of force and displacement. It is the dot product of force and displacement. Students, I hope you already learned about the dot product and cross product of two vectors in Unit 2 under the concept of vector. Therefore, when two vectors are added, the result is vector. The difference of two vectors also is vector. But the product of two vectors might result in a scalar or a vector depending on the type of the product. For example, the dot product of two vectors will give us scalar, whereas the cross product of two vectors gives us vector. Therefore, in this case, work is a product of two vectors. What are those two vectors? Force and displacement. So, symbolically, we can represent work as work is equivalent or equals to, mathematically expressed as force, which is a vector quantity, dots with S, where F is force and S is displacement. When we try to determine the magnitude of force, the magnitude of displacement times the cosine of theta, where theta is the angle between the force and the displacement. It is the angle between the force and the displacement. Now, it's possible to find work as Fs cosine of theta. Never forget this angle. The angle is always between the force and displacement. Let's take massive body here. Let's take a box, for example. Suppose a force is exerted on this box at an angle of theta from horizontal. Let's take horizontal line, which is horizontal to the surface. Let's take the angle to be theta. As this force is exerted on this massive body, it might be displaced from this point to some other location. Let it be here. At some other time, it can be here. Therefore, as it is displaced, it covers a distance of s. Therefore, what is the work done by this force in displacing this massive body a distance of s? That's how we are trying to determine work. So work is given as what? The force F, and its component along horizontal is F cos theta. The horizontal component of this force is F cos theta times what? A displacement S. F cos theta times displacement S. This is how we determine mechanical work. Then what is a SI unit of work? What is the systematic international unit of work? Therefore, the systematic international unit of work, or SI unit of work, is the dimensional analysis of force and displacement. The SI unit of force is Newton. The SI unit of displacement is meter. Newton meter gives us joule. Joule, in honor of James Prescott Joule. Therefore, the SI unit of work is joule. 1 joule is equivalent to that of 1 Newton meter. 1 Newton meter. So this is how we determine the SI unit of work. Now, it's also possible to represent force and displacement vectorially. How? Let's write force using dots product like this. Let's represent force vectorially. Let's take force as what? The force component along the x-axis, Fx in the I, plus Fy in a j, plus Fz in a k. Let's take displacement S as Sx in the I, plus Sy in a j, plus Sz along k, where I, j, and k are unit vectors along x, y, and z. Now, work is the dot product of these two vectors. Therefore, vectorially, it can be represented as Fx in I plus Fy in a j plus Fz in a k, dotted with Sx in I plus Sy along j plus Sz along k. Sometimes it's also possible to use hat on the unit vectors. Therefore, the dot product of these two vectors gives us only magnitude, or just we should have to multiply the coefficients, Fx with Sx, not I with I, while we dotted I with I, result is 1, plus Fy, Sy, plus Fz, Sz. This is how we determine work. Then, there are factors which affect work, or in physics, for a work to be done, there should be 3 terms or 3 criteria must be fulfilled. What are those 3 criteria? So the factors or the criteria must be fulfilled for a work to be done. Are 1, there should be a non-zero force exerted on a given object. The force must not be 0, or there should be a non-zero force. Non-zero non-zero force, meaning the applied force must not be 0. If the force is 0, the result will also be 0. There is no mechanical work. The second criteria should be there should be displacement whenever force is applied. Therefore, we can say this as non-zero displacement. S should not be 0. While we are making this, force must not be 0, non-zero. Displacement must not be 0. The third criteria, even though there are force and displacement, sometimes there are cases where there is no mechanical work. What is that? The force and the displacement must not be perpendicular to each other. So they must not be perpendicular. Perpendicular. That means force must not be perpendicular to displacement. Students, let me ask you one question. Suppose a man carries a box and moves on a horizontal level road. Let's take it like this. Sorry for my drawing. Let's say that this is a man. It carries a box and it travels horizontally. Now the man reaches here. Students, did this man perform mechanical work? Please try that. Well, the answer is this man cannot perform mechanical work. Why? Well, there are different forces acting on this object. The first thing is the force exerted on the man is due to the weight. Let's take it here, that there is a weight of the object. This is the object. Mass times gravity gives us weight. Mass times gravity. While the man is exerting a force to resist this massive object, you have already learned in Unit 4 about normal force. The normal force is the force against the weight, or it can be the net force on a contact surface. Therefore, the contact surface is the head of this man, might be. Therefore, the man will exert a force upward. That force is the normal force due to the man, which is equivalent to that of the weight of the object. Then, does this object moving along the force? No. But the object is moving to this side. This is a displacement S. Therefore, the angle between the force exerted by the man, we can call it normal force, or we can call it the downward force is gravity. Therefore, there is 90 degrees between these two vector components. Therefore, when we calculate the work done, work is given as force times displacement times cosine of theta. When we substitute this, the force F, it can be mg, mass times gravity. The displacement might be there, but here, when we substitute the angle, it becomes cos 90. And we know that cos 90 is 0. Therefore, the mechanical work becomes 0. Students, did you get me? I hope you understand these concepts. For a work to be done, these three terms, these three criteria must be fulfilled. There should be a non-zero force, there should be a non-zero displacement, and at last, the force and the displacement must not be perpendicular. Now is a time of activity. Let me give you some examples and try to solve that. Well, the solution would be, first, you should have to collect the given parameters or variables. The given variables are what? First, force is given, vectorial form. Therefore, you should have to put it like this. 2 in the I minus 6j Newton. Whereas the displacement is given. Displacement is I plus 4j plus 2k. 2k. Now we are asked to find the work done. What is the work done? Solution. What is the solution? Well, to solve this problem, you should have to put the mathematical expression of work. Work is expressed as force dotted with displacement s. Then force is given as what? 2 in I minus 6 in j. This is the force. Dotted with what? Dotted with displacement I plus 4j plus 2k. 2k. What are the variables? What are the components of the force? Well, the components of the force are 2, which is 2, is in the x direction. We can call it fx is 2. In the y direction, we have force component along the y direction, which is minus 6, and the z component is 0. There is no z component here. Whereas here, the displacement component, sx, is 1. Here we have only 1. Whereas the y component of the displacement is 4, and the z component of the displacement is 2. By the way, it's possible to use a component, Coleman method and row method. You do have such method in Unit 2. Now, when we multiply this, 2 can be multiplied with 1i. Students, if you multiply I with j in Unit 2, vector dot product, result becomes 0. I dotted with j is 0. I dotted with k is 0. Therefore, I dotted with I is 1. Therefore, it's possible to multiply only 2 with 1. Here we do have minus 6j. You should have to multiply minus 6j only by 4j. If you multiply minus 6j with I, it is the result is 0. With k, the result is 0. Therefore, we can multiply only I with I, j with j, k with k. Therefore, 2 multiplied with 1 plus minus 6 multiplied with 4 plus. Here we do have the 0 component is 0, the z component is 0. We do have only 0. 0 times 2. When we multiply this, we can find it to be 2 minus 24 plus 0. And this gives us minus 22 joule. Work is minus 22 joule. Students, do you think that work can be negative? I hope you do understand this concept. Yes, work can be negative, work can be positive, as well as work might be zero. What is the meaning of negative work? What's the meaning of negative work? Well, when work is negative, it means that the force and the displacement are in opposite direction. They are parallel but opposite in direction. When force and displacement, we have already mentioned that, force and displacement are perpendicular to one another, the force is 0. The work is 0. When force and displacement are parallel, the work becomes positive. Therefore, work can be negative, work can be 0, or work can be positive. Okay. Therefore, now let's try to add one more exercise or one more example. Well, the solution of this answer would be, first we should have to collect all the given variables. What are the given variables? What are the given variables? First, what is given? Force is given. Force F is 100 Newton. The other thing is angle is given, which is 37 degree. And displacement as well is given, which is 4 meter. 4 meter. Then, sometimes it's possible to sketch those problems. Okay? Easily you can draw like this. For example, here you have the mass here. The force is acting at an angle of 37 degree from horizontal. Like this. The force is 100 Newton. And it is displaced 4 meter. Now we are asked to find the work done by the applied force. Actually, there are different agents force exerted on this mass. There might be a frictional force, there might be gravitational force, or some other forms of force or types of force. But here we are asked to find the work done by the applied force. Then we are asked to find the work done. Work done. Solution. Our solution becomes, we know that work can be represented as force times displacement times cosine of theta using magnitude, or it's also possible to use F dot S vectorially. Therefore, F times S times cosine of theta. F is 100 Newton, the displacement is 4 meter, cosine of 37. Students, I hope you know cosine of 37. These are common angles, 37, 53, 90, 45, 30, and 60 are known. But it's possible to find on standard physics books or mathematics books. So cosine of 37 is equivalent to that of sine 37, which is 0.8. 100 times 4 times 0.8. And this gives us 320 Newton meter. Newton meter is already known to be joule. 320 joule. That is the work done. That is the work done by the applied force. Now, students, let's try to see the different forms or types of work. The different types of force. There can be constant force, or there can be variable force. I hope in lower grade you have also learned that force can be categorized as contact force and non-contact force. But here, let's try to see only the mechanical forms, like frictional force, gravitational force, applied external force, work on a variable force like spring force. Therefore, work done by constant force and work done by variable force. We can categorize it into two. So students, next time we'll try to see about the work done by those applied forces. For today, it's all that I got. See you next time.